Let's continue with 5.1 for finding the length of a circular arc. If you looked at the page in my math lab for your book, you would see that we're looking for a formula. The length of a circular arc length is equal to the radius times theta. Radius times theta, and the big deal is that the radius has to be multiplied by theta in radians. So if you are given a degree measure, it must be converted to radians. So arc length, S, is equal to your radius times your angle measure, that's theta, in radians. Let me see if I can emphasize that one more time. In radians. So let's practice some problems like that. The directions for the example A in your textbook ask you to find the length of a circular arc where the radius, circle has a radius of 10 inches, and find arc length, length of the intercepted arc, for a central angle of 120 degrees. So if we looked at a diagram of this, this is 0 degrees, this is 90, this is 180. 120 is 60 degrees above 180, so 120 is in this position. We are looking for the arc length, which is the length of this segment or this piece of the circumference. Again, we emphasize that the angle measure must be in radians, so the first thing to do is either use your unit circle or use your radian conversion measure ratio, which is pi over 180, and change this into a radian measure so that the formula works out properly. This ends up, zeros cancel, 6 goes into both 12 and 18, 6 goes into 18 2 times, 6 goes into 18 3 times, and that is 2/3 pi for a radian measure for 120. Now we can use that formula, arc length equals the radian measure, the radius measure times theta in radians, or 10 times 2 pi over 3. This works out to be 20 pi over 3 inches for the length of the arc. That is an exact measure. If they ask you to round that off, you could use your calculator and type it in and get an approximation. We'll do maybe to 2 decimal places. Now clear my calculator out. I know that this is a fraction. 20 pi over 3 equals, that's in fraction. I use the fraction to decimal conversion, and that changes it to about 20.94 inches. Now we know the length is 20.94 inches for that part. Here's one for you to try. We're looking for the arc length where a circle has a radius of 6 inches, and we want to find the arc length for an angle that's subtended by that 45-degree central angle. You'll be both expressing your arc length in terms of pi, and you'll be rounding to 2 decimal places. Yes, I know my handwriting is not wonderful. We're doing what we can do. Feel free to pause your video. I'll work the problem out in the process, and then you can start it again and view. See how you did. Okay, how'd you do? So did you remember on step 1 to convert 45 degrees into radians? That's by, you can use your unit circle measures that you have already created, or you can do that ratio calculations to convert. It becomes 45 pi over 180, which is pi over 4. Step 2, your arc length that's subtended by the 45-degree angle, the pi over 4 radian, is the radius times theta. The radius is 6. We found theta in radians to be pi over 4. That becomes 6 pi over 4, which reduces to 2 pi over 3 inches. That's our exact answer for part A expressed in terms of pi. And then the B part, use calculator to convert 2 pi over 3 into approximately 2.09 inches.